So what we're going to try to do, we're going to try to make this as interactive as possible. You've got me for about the next 50 minutes. I'm also going to be here all day tomorrow and all day Thursday. You're going to hear me ad nauseum by the time this whole thing is over, talking about modified atmosphere packaging and packaging films, what it can do for you, what it can't do for you, which is almost as important, and then some of the technologies around that. And then at the very end of the course, we're going to talk about what's coming down the road. We're going to talk about scientific platforms, which MAP becomes, and all the other technologies that we begin to hang on it. So, Jeff Breck gave you a fantastic introduction to the science of modified atmosphere packaging, the practical applications of the science. So, packaging fresh cut produce. So introduction, the history, the possibility, the challenges. It's an interdisciplinary design. One of the reasons I started my company many, many years ago is that the produce industry and the packaging industry have two completely different languages. And they didn't really talk to each other very well. So one of the things that we do is attempt to bridge that gap between the packaging industry and the produce industry. So for those of you who are processors, you can take some of this information back and talk to your suppliers so you can have a more constructive conversation. And of course, if your suppliers don't know the answers to some key fundamental questions, possibly a red flag should go up. So what is it that you want out of your packaging? Fundamentally, all packaging does is keep what's in and keep what's out. There's two exceptions. Fresh cut produce is one of them, or produce in general, fresh produce, and the medical field. And in those two industries, we have this synergistic relationship between the package and what's being packaged. Generally, if you're packaging shredded cheese, it sits there. It doesn't do anything. And your whole goal in life is to keep what's in and keep what's out. But as you heard Jeff say, we actually want gases to move in and out based on this living, breathing organism that we're packaging. And makes no mistake about it, if it's fresh produce, it's alive. It may be slowly dying. We call it senescing because it sounds more technically sophisticated, but it's still alive. It's consuming oxygen, it's giving off carbon dioxide. So the goal of the packaging is what? It's to keep it alive as long as possible. We make it comfortable, we rest it, and we allow it to live out its life and increase shelf life and maintain quality. Now, before I get too far, I've already had people come up and say, got to increase my shelf life. And I can tell you when I started my business, started this portion of my business in the late 1990s, it was all about shelf life extension. Gosh, could we get it out to, no matter what Marita and the scientists were saying, the industry was saying, you know what, we need 30 days. Let's get 30 days. So we in the packaging world said, sure, we'll try to get you 30 days. One of the reasons that we could do that is that in North America, we used to like a little bit of salad with our salad dressing. And if you put enough mayonnaise-based chipotle, bacon, ranch, blue cheese dressing on leafy greens, they become a texture. You actually don't taste them. You taste the salad dressing. Then all of a sudden, the European model in healthy living came around, and lo and behold, well, maybe we shouldn't have so much of this mayonnaise-based salad dressing. And maybe we, for those of you who are from Europe, who have been to Europe, a little salt and pepper, touch oil, touch of vinegar, and oh my goodness, we actually want to taste the leafy green. Well, guess what? At 30 days, it didn't taste so good. So it's not about, sure, if you've got 2 days shelf life and you want to get to 10, it's about increasing shelf life. But it's not just about increasing shelf life. It's about maintaining quality throughout the shelf life. I remember, and I know some of you know him well, Brian Zamorati, who's a legend in this industry. He's now with Curation Foods. I remember when he was at ReadyPack years ago, I came up to him and I was representing a company who had a new technology. I said, Brian, how much would you pay to get this technology because it's going to give you an extra day of shelf life. He said, Jeff, you're asking the wrong question. He said, I don't want an extra day of shelf life. What I want is on day whatever, 10, I want it to look and taste as good as day 1. And if you can sell me a technology that will do that, I'll pay for it. But don't come to me and say, you can take me from 10 to 11 or 13 to 15. It's all about optimizing that quality throughout shelf life. So how do we do that? Well, there's all kinds of things we can do. Modified atmosphere packaging is one of them. And it truly, and we're going to talk about it later on, it has truly become a technology platform. Jeff mentioned it in his earlier talk. We're actually going to talk later in the week about how we can incorporate ethylene management or antimicrobial management or water control management or humidity management into a modified atmosphere package. But, and why is this important? And this is about a year old, so it's even somewhat outdated compared to what it is today. But chefs are taking fresh produce, primarily vegetable and secondarily fruits, and promoting them to the center of the plate. We're no longer the little guys on the side. Suddenly, we are the main dish. Vegetables often now have their own category on menus. Retail store sales growth in the fresh perimeter departments, meat, deli, produce, bakery, and seafood, are surpassing that of the center store. When I first started this business, back when Christ was a corporal, the center of the store, the canned goods, was the main part of the store. Now the stores are actually defining themselves by their fresh produce department. That's the first thing you come into when you come into the store. So by gosh, it better be good if it's going to be how the store defines itself. Today's retailers cannot afford to ignore fresh. With 99% of U.S. grocery shoppers buying fresh products, fresh perimeter aisles have become key places where grocers can establish their identities. And the next time you go into a fresh produce section of your store, look at all of the non-fresh produce things that are trying to glom on to that section to make them sound fresh so that they increase their sales. Croutons generally are not a fresh item. Soy bacon bits are not generally a fresh item, but yet they're part of that department so they can grow their sales. So the future is now. It is a very exciting industry to be a part of. However, if you don't make it right, the rest of it is all for naught. Only the foolish build their homes on sand. We have to understand the fundamentals. And I cannot tell you how many people come to us and don't understand the fundamentals of modified atmosphere packaging. And it's not as much as what it can do for you, but actually what it can't do for you. Because people have this feeling that, or this gut feeling, that if I just had the right package, all my problems would go away. Now, I make my living in packaging, so it'd be easy for me to say, ooh, you're right. Just get the right package and all your problems are going to go away. Ladies and gentlemen, that is so far from the truth. As I think it was either Jeff or Marita mentioned it earlier, modified atmosphere packaging is an augmentation technology. 80% of your quality and shelf life is going to happen with things you do before you put it in the package. So do not think that if you just design the right package, your problems are solved. Now, if you do everything right on that 80% and you design the wrong package, it's going to go south real fast. So we can make a real negative impact. But it's not an end-all, be-all technology. It's a tool. So these are Jeff's fundamental truths. Number one's probably the biggest one, and we'll talk about what that means in just a minute. Anytime you place fresh-cut produce into a sealed package, you have created a modified atmosphere. You don't have to gas flush it. You don't have to do anything. Just the simple act of putting it in the package, because you're packaging something that's alive, that's breathing in oxygen, giving off CO2, as in Jeff's notes, said you're starting off with 20.7% oxygen, 300 parts per million CO2. The moment you seal that package, the oxygen is going to drop because it's being consumed by the produce, and the CO2 is going to go up. Boom, modified atmosphere. It's no longer 20.7 and 300 parts per million. So that's all you have to do. People assume for a modified atmosphere packaging that you have to gas flush it or you have to do something else. No, you just got to put it in. Now, is it right? Is it optimized? If you're real lucky and the packaging gods are smiling on you, it's not too bad. But more likely than not, you've got it completely wrong. But it's still a modified atmosphere package. It may not be correct or desired, certainly not optimized, but make no mistake. And then begins the question, okay, so how do I do it? So we have been talking this morning about this area, produce physiology, and pre-harvest and post-harvest technology, and produce biology, and how all of that impacts how we're going to package it. But we've also got the packaging equipment. How are we going to do this? We've got the film choices, and then that's all surrounded by marketing and the customer. What do we want the package to look like? What do we want it to feel like? Does it have to be sustainable? Does it have to stand up by itself? Is it going to be printed? All of that is put together when you're designing the package. So we actually live in a fairly small little area when you're actually designing a modified atmosphere package correctly. For instance, Jeff said earlier that, was it carrots, Jeff, or you needed the 500 cc package? I can't remember what it was you were putting in there, and you said 1 mil polyethylene would hit that 500 cc's, and he's absolutely correct, but I'm here to tell you 1 mil polyethylene could never make it through a piece of packaging equipment, and it'll never look good on a store shelf. So even though from a scientific standpoint it works, from a market appeal, from a machining and all of that, it's irrelevant. So then we got to figure out how can we meet all of those other parameters. So, as we talked about, O2 comes in, CO2 comes out. The product is capturing that, sucking in oxygen, giving off carbon dioxide. So we have to design the package to be able to meet that respiration. So, I'm packaging broccoli. I'm packaging romaine lettuce. Same quantity, same package size, same package? Absolutely not. Totally different, because the respiration rate of the broccoli is different from the leafy green, and the atmosphere that it wants to live in to optimize its quality and shelf life is different. I can't tell you how many times people have come to me and said, Jeff, I need a salad bag. No such thing. Well, yeah, just give me your salad bag. I see them on the shelf all the time. Nope, you got to give me a lot more information to say what a salad bag is. And here is that equation again. I think you all ought to keep it lit up on your laptop overnight so that it slowly begins to seep in as to what it is. It is a fairly, and as Jeff said, it is a simplified version. When we actually at our company do all the modeling and whatnot, it's much more complex. Fundamentally, following this in some kind of form. And there are a couple of key points that are in here. One is obviously you need to know the desired oxygen. What do you want to get down to? Do you want 0.5% oxygen left in that bag? Do you want 5%? Do you want 3%? How much CO2 do you want? And then you have to understand what the respiration rate of your product is. And as Marita and many others have already said, it depends on cut size, it depends on cultivar, it depends on growing region, and it depends on the proper type. We even have data in our company that shows the difference in respiration rate between hand cutting, machine cutting, and cutting with dull knives. And it can, in fact, make a difference. Is it enough that you would need a separate package for that? Not necessarily, because there's one thing on here that's not, I'm sorry, there's one thing that's not on here that overrides everything. What is it? Well, yeah, there's that too. Leave it to you to bring up the C word. No, there's one technical parameter that you should know by now that overrides, bingo, temperature. I can design a beautiful package for you, and if you lose temperature control in your distribution channel, that package could do more harm than good. It certainly isn't going to optimize for you, and you're going to hear it. You're going to hear it ad nauseum over the next 3 days, the importance of temperature. Marita was very generous. She only said it 4 times. I say it a minimum of 5 up to 10, and I'm the packaging expert. It is so crucial in fresh cut produce. Produce is a different story. But fresh cut produce, when you're putting it into a package that has very, very specific transmission rate properties that are very, very quantifiable, and that produce changes 2 to 4x, you're going to have a bad day, and you're not going to have the product that you want. So you can see here, this is just a slide. And don't forget, all of this is accessed in the download. You can see here some of the differences that different products have in the target O2 value that they desire. So, and this gets real interesting when you're in, somebody's already brought it up to me earlier today at lunch. She asked a lot of great questions at lunch because she wanted to be able to sleep through my presentation, but I told her I'd keep an eye on her so she couldn't. When you're doing combo meals, you know, let's say I want to combine broccoli with butterhead lettuce and spinach. How do I, in one package or tray, how do I design that? How do I figure out what's going to make sense? And even more so, and there's at least a couple of you in here that design or that sell packages that combine produce with a protein or a carbohydrate, which needs oxygen barrier. But if you put a total oxygen barrier on your package, your produce is going to go anaerobic, and you're going to create the off flavors and the off odors. So that's, and we're going to talk about more about this, and I'm available afterwards to talk about more. That's where a lot of the science and the art comes in to designing fresh produce packaging, is how do you take into account, it's one thing to do it for a single raw material. If you've got 10 raw materials and a protein and a carbohydrate, it becomes a little bit more challenging. Gas flushing. Gas flushing, and Jeff mentioned this, gas flushing, ladies and gentlemen, is a tool, not an end-all. It is a tool that is used when you're faced with enzymatic browning or what are called pinking. You want to get that O2 level down because remember I said by just putting the product into the package, you're going to drop your O2 and you're going to increase your CO2. But as the first half of Jeff Squared mentioned, it's going to take multiple days to get you there. You've got something like a romaine or an iceberg or a butterhead that browns or is susceptible to browning, depending on some of the pre- and post-harvest qualities. You want to get that oxygen level down quicker. So you can do that with gas flushing. But if you don't have the properly designed package, what's that gas flushing going to do? It's going to cause you to go anaerobic that much faster. This line is just going to head south because you're not letting enough oxygen in by not having the package designed properly. So gas flushing is great if you want to drop that oxygen level in the package down very quickly. But if you don't have the package designed properly, potentially you can go anaerobic much faster, which is going to leave you with a lot of off flavors and off odors. So doing gas flush without a properly modified atmosphere can sometimes do you more harm than good. So it is a tool. It is not a replacement. And people very often, especially early on in this business, people would read in literature, oh, I need 2% oxygen and 8% carbon dioxide. So they'd go out and from Air Liquide or a gas company buy a mixture of 2% oxygen and 8% carbon dioxide, and they inject that into the package, and I'm done. What's wrong with that? Why won't that work? Respiration. Exactly. Because that 2% oxygen, 8% carbon dioxide is only going to last for a fraction. And then the produce is going to start breathing again, and it's going to do its thing, and the thing is dynamic, and it's going to continue to change. So you have to design these things properly. So there's also the marketing, appearance, construction, graphics, stiffness. I like to use the E word, sir, not the C word, economics instead of cost. Some people use the P word, price. It all sort of means the same thing. You have to design it. I can design you guys a package that is incredible, but it's going to cost way too much money. So how do you factor all of that in? And then there's the converting requirements. These are the things people very often don't take into account. The dimensions, the construction type, how are we going to seal this package, the equipment that it's going to run on. Does it have to be stiff? Is it going to lay down? Is it going to stand up? Who knows what this little interesting word is, COF? Anybody know what COF stands for? Oh, coefficient of friction. How slippery the package is, or not slippery. And if you're running this on what's called the vertical form, fill, and seal, and I'll show you that in a few minutes, it's got to be slippery in order to get over the packaging equipment. But if you're running it on a horizontal packaging machine, you don't want it too slippery. And I'll give you a classic story about COF. There's actually more rejections in packaging due to COF than almost any other one, and it's one of the least known parameters in packaging. I did back in the, way back machine, 1988, I designed the package for the Bic lighter, the Flick Your Bic. You don't see them much anymore, but back then they were a big deal. I came in, hotshot packaging engineer, to the Bic, and they were and I walk up to the packaging machine, and I'm looking, and the foreman comes up and goes, you know, you might step back a little bit. I said, why? Is it a tough union or something? He goes, no. Literally, seconds later, boom, one of them blew up because the packaging was too slippery, and the Bic lighter would move, and the sealing jaw came down and nicked the end of the lighter, and the thing exploded. So I'm like, oh, wow, tight specification on COF. He goes, yeah, very tight, because it's got to move a little bit, but it can't move too much. So these beta value, we talked about that. Jeff brought that up. This is a biggie, ladies and gentlemen, because we're going to talk about microperforations in a minute, and they have a beta value of 1 to 1, and packaging films has a beta value of about 3 to 1 on average, as Jeff mentioned. So if you want 2% oxygen and 8% carbon dioxide, you can't get there with a microperforated film. Because a 1 to 1 ratio means if you have 2% oxygen, you're going to have 18% CO2. Problem, though, is in some cases, we have to use microperforations because our packaging films are not breathable enough. So this is where we begin to get into these compromises of what's important and how we're going to design this package. Microwave cook-in requirements. How many people sell a microwave cook-in product? Anybody? That's good. Microwave leafy greens are not great. You do? Leafy greens or vegetables? Like spinach or something? Or? Okay. Two functional things about microwave cooking. First, you don't want the package melting in the microwave around the food, generally frowned upon by the consuming public. Second of all, you want it to comply from a regulatory standpoint. because as you heat the product up, polymers, they become more amorphous. They let things move through. And the FDA is very sensitive about what they allow to migrate into food. And so if your polymers are not regulated or applicable for microwave, you can inadvertently be adding chemicals into your food that you're not even aware of. Case in point, I designed the package for the original Nasoya tofu package. It was a great package. I mean, it was a great package. 6 months later, the head of Nasoya Food comes up, and he is screaming at me in his native language. And he was not a happy man. And it took me a little while to figure out what was going on, but and this package was a tub with a beautifully printed lidding film over the top. And you opened up that lidding film and you got the tofu. Well, about 6 months in, and I don't know why the consumer didn't like this, but the print job was impregnating itself onto the tofu. It was frowned upon. Long story short, I went up there to try to figure out what happened. There was a new piece of equipment in the processing line. Sir, what's that? We're pasteurizing now. I said, oh, you're cooking it. No. We're pasteurizing it. Well, tell me about that process. Well, we put the tofu in the tub, we seal the tub, we put it in 180 degree Fahrenheit water for 3 hours. Then we take it out, we put it in 34 degree water for 3 hours. We're pasteurizing it. I said, no, you're cooking it. And I didn't design the package to do that. So the polymers had become amorphous, and all of the inks leached right through. And I want to tell you, it was a nice print job on the tofu, if I do say so. Okay, so we've got filling machine requirements, seal type, filling machine, sealing conditions. Do you want a fin seal or a lap seal? These are the kind of details that you need to think about when you're starting to. Lap seal is you seal front to back. Fin seal is you seal back to back. So in a fin seal application, you can use polymers that are only sealed on one side. On a lap seal, you can you have to use polymers to seal them on both sides. And I can see some of you thinking, oh my God, who cares? Well, if you buy a piece of packaging equipment that's designed to do it one way, and your film manufacturer doesn't know it, and they design it to do another way, you're going to have a whole bunch of packaging that doesn't work. Or are you hand filling? And then how so all of these details, and I don't want to overwhelm you, and a lot of this your packaging supplier should be able to help you with. By the way, your packaging supplier should be a technology resource that happens to supply packaging. If all they're doing is supplying a package that's a few fractions of a cent less than the other guy, they are doing you a disservice. They should be a resource. They should understand all that. We do, and we help customers help their packaging suppliers understand these. But look at your packaging supplier as a resource, not just as a way to get a tray or a box. So here's that vertical form, fill, and seal I was talking about, where you're taking a roll stock, you're moving it over a forming tube, and you're making a bag. This is how all snack food packaging is done. And so you can see these little, what they call the forming collar and the forming tube. Those are made out of stainless steel, so your packaging has to be slippery enough to make it over that, so that you can actually make the package. The classic example of a non-slippery bag is when you go to Home Depot or wherever and you're buying dirt or compost, and you those big pallets, all those bags. Those bags are tacky, because otherwise you take one bag off that pallet and it's going all over everywhere. So you can't have slippery bags on that. These are just fun facts to work at cocktail hour, ladies and gentlemen. Okay, so you have your seal type. Do you want to put in a zipper? Do you want an easy peel feature? Do you want it to be reclosable? So you've got, and here's a horizontal, so there's 3 different kinds of horizontal form, fill, and seal machines. Now I know I'm moving fast because I've only got a certain amount of time, and I want to try to at least expose you to it so you can furiously write down questions you want to ask later. Because I'm going through a semester worth of classwork here, in about 45 minutes. Another type of horizontal form fill. This is usually a sauce packet or a seasoning packet, also known as a horizontal form fill and seal. And then you've got this kind of horizontal form fill and seal where you have a tray and produce and a lidding film over the top, all referred to as horizontal form fill and seals, all significantly different from each other in what kind of packaging products they use and how you get breathability. Rigid containers, clamshells, two-piece containers, trays. So, how many of you use a clamshell with a snap-on lid? Modified atmosphere? Yep. APET clear tray, APET snap-on lid, both tremendous oxygen barriers. If it's snapped on tight, we'll go anaerobic in 48 hours. If the snap-on is loose, you won't modify the atmosphere at all because you've got all kinds of oxygen coming in. And if it's somewhere in between, you'll sort of modify it. We refer to it as natural aspiration. Yes, you're doing a modified atmosphere package. Is it in control? No. You could have some packages that are going anaerobic and some packages that aren't even modifying the atmosphere at all because the snap-on is loose, and there can be that much variation. Understanding, again, this concept of just putting it in the package and sealing it up, the produce is going to do its thing. And if the package can't react to that, you're either not going to modify the atmosphere, which is going to shorten your shelf life, or you're going to cause it to go anaerobic, which is going to also shorten your shelf life and give you the off flavors and the off odor. So thank you for doing that. There's also peelable packaging now. It's becoming very popular, peelable and resealable. So you can open it up, you can pull something out, you can seal it back up again. Great technology, but very much complicates how you're going to make this package and the polymers that you can use and how you get it to peel and reseal. So in a lot of these tray applications, when you get into rigid packaging, those polymers are barrier polymers, either because it's polyester, which is an oxygen barrier, or because it's so thick, in effect becomes a de facto oxygen barrier. So in that case, in a case of a rigid APET tray, and you've got a lidding film over the top, say something like this, a peelable lidding film, how does surface area impact your calculations? Remember in that, if you go back to that thing that you're going to put under your pillow tonight when you go to bed, the big equation, remember surface area was in there? So how does surface area factor into these kinds of trays? Right, that's right. So suddenly your surface area, you're absolutely correct. Suddenly the surface area now isn't the whole package, because 3/4 or 2/3 of your package is a barrier. The surface area that you have to work with is very, very small. It's that lidding film, that thin lidding film. Now, if that thin lidding film is made out of polyester, in order to be able to seal to the polyester tray, you've again created a nice barrier. So you use perforations. If it's not a polyester and it's a breathable polymer, it's got to be really breathable, because you've only got a fraction of the surface area of that package to play with. And breathability, as Jeff mentioned, and I think Marita and others have mentioned, you try to look at as much of that tray as you can. So let's think about that for a second. Let's go back. Okay, here's our rigid tray with our peelable lidding film over the top. And we've got tomatoes, carrots, celery, I'm not sure, broccoli maybe more carrots. What's the challenge? And we've got a lidding film on top of that that's got a whole bunch of little micro perforations allowing air and carbon dioxide in and out. What's the challenge with that package?
Respiration rates.
Well, different respiration rates, that's one. Excellent. Different
Cut sizes.
Yep, different cut sizes, but I'm talking about the package itself now. But down below the package, you may be going anaerobic. So this is one of the challenges, not insurmountable, but one of the challenges when you use this style of package is trying to get enough airflow around that package. Let me take it one step farther. You create a great package, and then you put that in with 20 other packages into a case, and you seal her up. And then you package 30 of those cases on a pallet, and you strap the bejesus out of it. You've actually created 3 packages. You've got your primary package, which is the one we designed. You have your secondary package, which is the case. You have your tertiary package, which is the pallet, and each one of them, depending upon how much they do or don't leak, is a modified atmosphere package. And then we even now are designing containers to be the modified atmosphere package, shipping containers, where, you know, for instance, a vented blueberry tray, which is not a modified atmosphere package because it's completely vented. We are actually creating the entire shipping container to be the modified atmosphere packaging. Same calculations, different dimensions. So when you're looking at how you're going to ship this product, you need to think about, is your secondary and tertiary packaging impacting it? And if so, do you need to alter it some way? Do you need to go to a vented carton? Do you need to go to a roping stretch wrap where you're not completely encasing it? Anytime you put packaging inside a sealed container, you've created a modified atmosphere packaging. How long is it going to be in the secondary and tertiary packaging? Is it going overseas on the ocean where it could be in it for 30 to 45 days? Then those packages become very critical. We talked about stand-up pouches. Here again, the polymers that are ideal for increasing stiffness, so not good for allowing oxygen and CO2 in. We need to look at potentially microperforations. But we understand microperforations will only give us certain atmospheres, so we have to take that into account. Perforated films. There's macro perforated, there's micro perforated. The rule of thumb is macro is visible to the naked eye, micro is not. A macro perforation is not a modified atmosphere package because it's going to allow so much oxygen in that it's not actually going to modify the atmosphere. A micro perforation is very much a modified atmosphere package. Yeah, there's some old Crunch Pack packages up there, isn't it? Yeah. Usually made by a laser, although, and I'll talk about this on Thursday, there's actually some new micro punch technology that's going to be coming on stream in the not too distant future. Perforated packages are usually useful for products with a higher respiration rate. I think Jeff mentioned that as well. Tends to be low to moderate O2 with moderate to high CO2. You cannot have low O2 and low CO2. So, are breathable polymers better than microperforations? Or microperforations better than breathable polymers? Depends on the application. One is not a superior technology to the other. They're both tools, and you learn to where you want to apply the proper tool. Water vapor transmission rate. Now, here's a bit of a bugger, ladies and gentlemen. Almost every polymer that I've talked about is a magnificent water barrier. It does not let water out. So whatever water's in that package is going to stay in that package and potentially increase. Now, there's a lot of work being done to increase water vapor transmission rates, but it's still not quite there yet. So you need to understand that whatever package you're putting it is, from a polyethylene to a polyester to whatever, you've got a good water vapor barrier, which in some cases is a very good thing, but in other cases, if you're hoping to get some water out of the package, your package is not going to do that for you. Okay, so this is a series of slides talking about specific types of polymers that can be used in specific situations. And I'm going to not really go over them. If you want to talk about it later, we can. You've also got copies of all this, so you can read it in the privacy of your own room. Materials and characteristics, sealant layers, characteristics. So one thing about this slide, though, when you look at a single piece of plastic film, everybody assumes it's one layer, but more than likely it's not. But it's important to understand that when you're looking, when you are looking at designing transmission rate of your film, you've got to go through each layer separately. So if you have a multi-layer film and you've got a 70 cc laminated to a 1000 cc film, transmission rate. The transmission rate of that total lamination or that total film will never be more than 70 because it's got to get through each layer independently. You can have a 70 gauge or 70 cc film attached to a film that's infinite and it will never be more than 70. When you're in your and this is something your package design supplier or your package design people should know very, very well. And there's actually ways that you can calculate that. So this is Jeff's corollary packaging truths, because I've got about, what, 10 more minutes, 5 more minutes? 2 more minutes. Oh, my God, killing me. Okay. How important is temperature control? Have we got that yet? The most important. Cold chain management, therefore, becomes, or distribution temperature management becomes a big deal. And Jeff said it earlier. What temperature are you going to design the package for? How many of you had in your quality control case a great looking product, but then you get a complaint from the grocery store that it doesn't look so good? Well, you've kept yours at a constant temperature, and theirs has been all over the map, potentially. So what temperature do you design your package at? Is incoming product quality important? Yes. You will, and I'm going to say it point blank, packaging will ever improve the quality of the incoming product. Period. Copy that. You got garbage going in. Keep it good garbage for as long as we can, and then it's going to go downhill from there. But it is never going to improve that garbage. So post-harvest technology is important. Here's a big one, ladies and gentlemen, the L word, leakers. If the package leaks, it's not optimized. Modified atmosphere packaging only works in a leak-free environment. And that's easier said than done, and I know that. Gas flushing, tool or indol? Tool. Is this a static environment? No. Does one product fit all? No. Choosing the packaging the week before launch guarantees a non-optimized package. I know it's just a package and we can, figure it out just before we launch, no big deal. Not going to work, ladies and gentlemen. Conclusions. You need to have a thorough understanding of the requirements and desired results. Not just the post-harvest. It all starts with the produce. But then there's everything else. How are you going to package it? Is it going to be on equipment? Are people going to do it? What's it going to look like? What are the cost parameters? All that has to be factored in. And it's about compromises. What's the most important? And what can I slide on other things? Matching requirements to properties. Understand the language, selecting the proper package, designing the proper package, and ongoing quality and testing. Does that make sense? I'm done, Angela. Thank you.